Okay, we're back. It's Friday afternoon, about 4:30. It's starting to get dark around here. Yeah, the UPS guy just finally showed up. Well, it was supposed to be, my stuff was supposed to be here yesterday. I'll have a rant at the end of this about United Parcel Service versus the United States Postal Service. Not a big fan of the guys in brown. How's that? If that makes it any easier for you to decide which way I'm going to probably go on that. We are currently removing the rest of the solder from the socket, pin socket here, and so I can get the capacitor, the new cap, fed through here. Now I like to try and clean out. I desolder as much as I can, then unwind the wires like Mr. Carlson shows with a nice sharp pair of diagonal cutters like these Aram diagonal cutters. You can just get right underneath the edge of the lead and just unwind it like unzipping a tin can. Really works great for getting the leads off of any kind of pin, contact pin. These turret style or the eyelet style, or even the the binding posts. That works pretty well. Now, I don't think that's quite good enough. We're going to give it a little bit more here to sop that solder out of the hole. This is good. I love this MG Chemicals Super Wick. It is really good stuff. I like even better is the solder sucker, vacuum powered solder sucker, and that works best on printed circuit boards. It doesn't work so well on this point-to-point wiring style stuff. It's a little harder to get in. And then this, a lot of these, I noticed they're cut. The pin is cut, so there's really no actual hole. It's just the edge of a notch, kind of. Now I got a little kink in this. I wonder if you can see that very well. Of course not. Okay, what I've got is a little bend right here to go around the turret. Here, let's zoom out. Wrong way. Okay. So you get the idea here. We're going to wind this edge of the this part of the lead around there, and then this one will slip down through here, and I'll wind up probably cutting that off about right here. I usually save the leads, especially the nice fat ones, and save them in a jar for, they come in handy for all kinds of things. So, and then I'll put that right in here like this. Okay, first thing we'll do, get some RA flux. Nothing works better than a good RA flux when you're trying to get the solder to flow. Yeah, it gets all over everything. It's nice and sticky, but that's the way it's supposed to be. Just a little dab will do ya. I got a jar of a solder bit wire here. Actually, it's a shot glass full of little bits. Get this nice and hot. And we'll put some, get that tinned up. There we go. That should be nice and firmly soldered in there. You can get a drop of flux on that. Put that down right there. Heat that up and put that, poke that through the put a little more solder on there. And we're gonna That looks good. And I put some of this, I get this fiberglass, silicone impregnated fiberglass tubing. I got from eBay. It's super cheap. I think it was about $2 or $3 a meter. And I got 1mm ID, 1.6mm ID, and 5mm ID. And it's just this, we're going to have a piece of it. Anyway, it's this tube, this pipe. It's hollow. It's got silicone on the inside, and it kind of feels like fiberglass, and it's sort of, it's real flexible. It kinks. It doesn't tube, but it's got 600 volt insulation rating, so more than ample for most tube work. Anyway, that's how you replace a coupling capacitor in a tube style device. I'm going to turn the camera off so I can go work a little faster here. I'm going to replace 1, 2, 3 these other 3 coupling caps, and then I'm going to flip over and show you how I do the I've got the the electrolytic capacitors that for the power supply, and you know, compared to the original, it's pretty impressive how small things are now. Alright, so I'll be back in a little bit when I got more to show you. Alright, fantastic. Here we are again. Now I've got these 3 coupling caps all replaced. These fat old bumblebees. I didn't check them for leakage. I just assume that when they're this old, they're gonna, you know, from 1947 or 8, they're probably not gonna be good. At one point, someone discovered this one up here had gone bad, and they replaced it with a Sprague Vitamin Q. Vitamin Q, so it must have a good Q quality. That's hilarious. And this one up here, and it's a 1 microfarad 600 volt capacitor, and that little guy replaced this. This thing feels heavy as it's all waxy and gross. Anyway, so we replaced all those. These have already, of course, been replaced. These are a 22, a 22, and a 47 to replace the high voltage, the B+ power supply caps, filter caps. Okay, so next on the agenda. Oh, and then I had these disconnected too. This is the output, so you can get an amplified output voltage out of this thing. I guess I could run it over to a digital voltmeter and see for comparisons and whatnot. Oh yeah, this, I don't know if you can see that real well. Let me get the light a little better there and get it out of the way of it. This is a 5600 k ohm resistor. That's a 1 watt resistor, and same as this one. I mean, that's the direct replacement. Let me hold this steady. Hold it steady. Pachinko the thing. Anyway, it's amazing. This thing is a third the length and a fourth the diameter, and they're rated the same, 1 watt. And it's right on spec. I checked it from DigiKey, so it's gotta be good. Anyway, alright, there's that stand. Alright, that's about all I'm gonna do for now. I don't kind of pull the leads off these caps down here. I'll pull that 100 ohm, and I've got another. I got a bag of 100 ohm 1 watt resistors. I'll replace that probably. I might even just leave it in there just for giggles. Anyway, I pull these wires off and set them up here and run them up. They'll be replaced by these 10 microfarad and 2200 microfarad capacitors. There's 5 caps go replace here. There's 3 here. Wait. 3 here, 2 here, and 2 here. 3, 1, and 1. So that makes 5. There's 5 caps. There's 1, 2, 3 here, 1 here, and 1 here. These are both 2200 microfarad, 15 volt, and these are the 10 microfarad, 450 volt. All right. I'll be back and I'll show you how I did that. I drilled the side of the aluminum chassis here, and I put a number 6 screw in a nut, and put this 4 terminal tie strip. I put 2 4 terminal tie strips up with a couple of screws, and That's what we're going to attach the capacitors and the wires to for the power filter supply. Alright, we'll be back in a little bit when I got more. Okay, we're back once again on the bench. I have managed to cobble together the proper amount of capacitors. Here's the 10s at 450. Here's the 20 or the 2000 these are 2200 microfarad at 16 volts. Here's a 100 ohm 2 watt resistor across the negative supply cap. This is the positive supply. This is the voltage regulator that turns the 6.3 volts AC into 6.3 volts DC to run the filaments for these 6AK5s. They run on DC filament voltage to keep the noise down, so this is a precision instrument. Had to run a new wire here. I used some really good build and 600 volt rated. Here's the other capacitors there. This was a 0.22 mic at 400 volt. Then I got this array of Illinois capacitors here. These are 0.22. These are the isolation caps, or they call them stage isolation, between the different stages of amplification for the 6AK5s again. Anyway, so we've got the filter capacitors in, the coupling capacitors. Here's a new one. We put a new 560k ohm resistor in to replace one that had gone out of way over. This 0.5 microfarad we replaced with a 0.56 microfarad, and also here we got a 1 mic. This is a 0.1 microfarad, and that's the AC coupling for so DC voltage won't get in here and burn this thing up. Anyway, let's see. Well, that's about it. I need to clean the contacts pretty well on this. I'll see how it goes. I'll put tubes in here in a little bit. Oh, and gonna need to do something with that. Anyway, I could wire this in with that just like that, but I'm gonna put the tubes in it, put a line cord plug on the end of the line cord, and stuff it back in the box and take a couple pretty pictures of it, and we'll fire it up, see what happens. Alright, we'll be back in a little bit.